said, my name is Zoonotic. I'm from Seattle, and I'm an emergency physician. And I'm going to talk about zoonotic disease today, meaning diseases that we catch from animals, and link that into kind of ecology and human health as a more broad topic. This is obviously a huge subject that we could spend a semester of classes easily going over. So this will be a little bit of a deep dive into a couple of processes. And we'll move pretty quickly through this because there's a lot to cover. So usually when I give this talk, less so here probably, but usually when I give this talk, people are like, why are you talking about this to an emergency medicine group of people? And to go into that a little about my background, is this was me 13 years ago, and I was a field biologist and worked on various projects, including disease ecology in birds. So we go out and trap birds and sample them and see what diseases were out there. Through this and that, sort of seemed like a good idea at the time. I went to medical school, and within about a month or two, I decided I had to sort of start linking back into some of the things that I was interested in before. And so I joined with a friend of mine who I'd worked in a lab with in Georgia, who studied bats and was interested in vampire bat rabies in Peru. And he was looking for somebody with a medical background to come kind of look at risk factors. So my first to second year in medical school was a big outbreak in Peru of rabies in the Amazonas, in the northern part of the country. And it was thought that really all of the rabies cases were due to vampire bat bites, and we're trying to figure out why this came out of nowhere. So this cute little fellow is the host, the vector in question. This is Desmodus rotundus. It's the common vampire bat. Lives all over South and much of Central America, and is a great vector for the rabies virus because they bite into a host. Their saliva comes in contact with the blood, and that's how rabies most likes to be transmitted. The rabies virus is the single-stranded RNA virus. You'll remember it's a bullet shape. And we'll talk a little bit more about transmission, but just a quick kind of picture of what we're talking about. And then this is how this guy transmits the virus. A little less cute in this picture. This is a cow. This is one of their favorite meals. And so they'll literally bite a little chunk of skin out of their prey, and they have an anticoagulant in the saliva, and those sit there lapping up blood, injecting saliva, lapping up blood, and you can see how rabies might love this. So this is a map of the rabies outbreaks due to a similar process in Central and South America over the last 30 years. Oops. Let's do this instead. So this is where we went. The biggest circle here was the outbreak in 2011. There's outbreaks all over the place. And the green there is the range of the vampire bat. So you can see it really extends. It doesn't like the Andes so much, but extends to South America and just about up to the border of the U.S. So this is a pictograph from about 500 AD from that region. This is the vampire bat god right here, attacking a human and making him bleed all over the place. So I don't know where this came from, but you can imagine that maybe people have been getting bitten by bats in this region for a very long time. And rabies is thought to be thousands and thousands of years old in relation to human contact and descriptions of the process. So this is something that's been going on for a long time, but outbreaks like the one that we've seen really have been escalating over the last 30 to 40 years, and there's very little evidence that they'd occurred before then. So the question is why? This is a close-up of the area where we were doing our work. So this is that little region of Amazonas in northern Peru, and then this is the Rio Marañón, confluence of a couple other rivers. And this area, this little town right here, was the center of the outbreak, a town called Yupicusa. There's a couple hundred people who live here, and you have to understand that these villages consolidated out of people living off on little kind of homesteads in the forest, where they had lived for thousands of years in that way. And really over the last little while started consolidating into small villages that you still have to access by a boat going up the river for hours and hours. There's still not roads really going through here. But there is a consolidation of people, and there are some livestock that are raised in the area now too. Let me see if I can get this play. This is a quick video from the area. This is some footage we shot while we were down there. So we're out trapping these bats. They're very cute. A little less cute. And so these are these villages where we're doing our work, and so these homes are pretty open to the air, right? And there's been a lot of campaigns with putting up mosquito netting and trying to figure out how you keep bats out. You know, most of the people getting bitten are children. Adults get bitten too, but the kids are the ones who say, I don't like this mosquito netting. They take it off in the middle of the night, and you know, maybe they're tastier prey, I don't know. And then a few of these larger communities are really surrounded by cattle fields as well. And there's some thought that those livestock are drawing in more and more of the bats, though they may also be sort of a protective barrier where the bats hit a flock of livestock and say, this is great, we don't need to go any further. So maybe in those cases they're protecting the humans from depredation. And that's just a few of the kind of pictures in more close up. So the kind of sad thing here is that in this outbreak it was I think 24 people total. 2 were adults, the rest were children, most were young school-age children. And this is a town of a couple hundred people where 21 young children died in 6 months of rabies, which is a rough way to go. I don't have footage from there for a variety of reasons, but this is a video from India that I think very well illustrates kind of the process we're talking about. And so you can see there's kind of distress and something you'll, you know, as you go forward clinically start to recognize as encephalopathy type behavior, acting strangely. And there's a couple classic things with rabies going on here. Erratic behavior, kind of aggressive, kind of confused. You can just see that excessive saliva production, trying to drink water but has hydrophobia and can't drink it. And so this child died within about 48 hours. And as you're probably aware, there's not really anything you can do about rabies for the most part once you see any symptoms like this. It's basically a uniformly fatal disease. Yeah.
Like I've seen that rabies causes hydrophobia. Can you describe that a little more? Like it seems like he wants to drink water.
Wants to drink water, but feels like he's choking on it and doesn't want it. And some people will not even try it, and some people will try it and just have to like spit it out. Yeah.
And is that the main mechanism of death? Is dehydration or?
No, it's an encephalitis.
Okay.
Yeah, it's massive inflammation in the brain.
Okay.
With other effects too. That's usually the cause of death. So just to back up for a minute, rabies is part of the lyssavirus family, and there's a lot of other groups of similar viruses. And the point here being that you'll notice in all of these different groups with all of these different vectors and hosts, you got bat, 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 bat. This is a group of viruses that have evolved along with bats, probably over millions of years, and have branched out into several different pathogens, many of which are pretty significant risk for humans. Zooming in on rabies, we think about 2 major clades of rabies. So you have the bat group here, which seems to evolve along with bats, and the canine group here. I think the proportions here are not entirely accurate. This was one study, but the point being you can see a major branch point here between these 2. It doesn't mean that they can't travel back and forth, but these are the vectors that they've kind of evolved along with and are most suited to. One of the interesting things is that a lot of the bat rabies seems to like more superficial wounds and is able to penetrate into the nerve tissue from superficial wounds, and the dogs like the deeper wounds into deeper muscle tissue. And you can imagine that kind of has evolved along with the size of the bite that's inflicted. And again, just to zoom in a little more, we got bats, and vampire bats are an incredible source of biodiversity and ecology for this virus. So worldwide, it's a pretty big problem. There's about 60,000 or so deaths per year, and it fluctuates year to year, but it's fairly steady. There were some strides recently that reduced that number, but it's been steady for a while. It's a major problem in India and Asia is really the area where it's worse, and that's mostly due to the persistence of dog rabies in those areas. So in Peru, where I was working, they've almost eradicated dog rabies, but there's still bat rabies, and in the U.S. similarly in a lot of developed areas. And just to put the kind of global impact in perspective, you guys remember this fellow? This is Ebola. This, obviously caused catastrophic outbreak a few years ago and reemerged. This has caused between 11 and 12,000 deaths total over several years. And so rabies is affecting globally on a order of magnitude greater. All right, we're going to take a break and go through a rabies case in triage haiku. Have any of you guys rotated through or worked in an emergency department? So you have your triage note. If you're working, it's the first thing you read. You say, why is this person here? So this is from a unnamed county hospital. Triage haiku. Requests rabies shots. An unknown puppy dog licked her lips this morning. So does this person get rabies shots? Anyone? Guesses? Throw it out there.
No.
I'm seeing a lot of shaking of heads. Okay, so it's a good question. I laughed. I saw this and I was like, I love this. I like rabies. This is hilarious. So let's talk about modes of transmission. Apologies for the language barrier here. This is just the best slide that really wraps all this up. So mortadura per animal rabioso. That's the bite. We all know that, right? Contact between saliva of the animal and a wound on the host. Okay, that makes sense too. Contact between saliva of the animal with rabies and the mucosa of the host. Okay, maybe she had legitimate concerns. And then this is aerosol in caves, and we were doing a lot of work in caves. We wore massive respirators. I never did that in caves before I went in caves, and now I always will, I think. And then obviously lab work, you can get exposed, and then transplant. So there was an actual case of, maybe it was about a decade ago now, where somebody died of an encephalitis that nobody worried too much about, and organs were transplanted into a variety of people who all got rabies and died. So it's very rare, but that is a definite way to contract rabies. And so this lady's presenting with this complaint here, so that's interesting. And so I think the crux of this comes down to where in the world are you and what's the risk if this puppy dog had rabies. And so she was presenting, let's say, somewhere in this area here, and interestingly enough, she had just moved from here, which is Bangladesh, where there's a whole lot of rabies. And so the puppy dog that licked her was here in the Pacific Northwest, and so we don't have to worry about it, but had she been back at home, she probably would have bought herself a course of rabies vaccination post-exposure prophylaxis. Quickly, this is the nicotinic acetylcholine receptor, the neuromuscular junction. I bet anyone in this room can tell me more about this than I can tell you about it, except that this is where rabies enters our nerve cells and where it gets to the place where it does most of its damage. You get the bite, you get the rabies slowly traveling into the nerve and then slowly traveling by retrograde transport into the central nervous system, where it starts to disseminate throughout the body, and it affects and replicates in salivary glands, and that's where the infectious process kind of, the most common source. It causes encephalitis, and it can affect kidneys and other organ systems as well. We'll just quickly go through the pre-exposure is 3 doses, day 1, 7, and 21. If you've been exposed and never been vaccinated before, you get 4 doses, 1 right away with immune globulin. The important part here, if you're doing this clinically, is that the immune globulin needs to be injected somewhere away from the vaccination. Otherwise, the immune globulin globs onto your vaccination, and you don't really get either effect very well. Yeah, you've kind of negated it out. And then you follows up on the 3rd, 7th, and 14th days. And this is highly effective. And if you've been previously vaccinated, you get 2 shots, 1 right away and 1 after 3 days. One of the guys I worked with who'd been doing field work with bats forever, he refused to wear the gloves. He wore these big cumbersome gloves, so unlike working with birds. And he's like, didn't want to wear them because they're like, in the way. So he'd get bitten like every month he'd get bitten and go in for a couple of shots. He was highly immune.
How long after exposure, can you give the vaccine and have it be effective still?
That's a great question. Until you have symptoms, go for it.
Okay.
Yeah.
How long is that prodromal period?
How long is the prodromal period?
Yeah, before onset of symptoms.
So the prodrome we'd consider when you start to have symptoms, but you're not sure what it is yet. The incubation period is widely variable, and that's one of the reasons it's a really hard disease to trace back, and sometimes people don't even know. It's from 1 week to maybe a year or more in some cases. Yeah.
Are there places in the world where they do pre-exposure vaccination?
It depends, yeah. So these villages we work in, they're working on a campaign to do that. Yeah, really high risk areas.
Are these the crazy painful ones that you put into your stomach?
No, so that's the old virus. So these are the available vaccines, and I don't want to spend a lot of time on this, but this is the one that we use in my hospital, and that it's going to be used in most of the developed world, and they're a regular shot.
Okay.
They're not painless.
Good to know.
They're not the worst thing you've ever experienced. All right. And then just real quick, the post-exposure prophylaxis, wound cleaning is the point of this slide. That's a really, really important part of this. And so it's thought to maybe decrease risk by about 90% just cleaning the wound with soap and water thoroughly. Who knows this guy? Anyone? Anyone? Cujo. Very good. What about this guy? It's older, old yeller. Or it's a sadder one. All right. So I have some slides about Washington, just because that's where I'm from and that's where I do most of my work. If someone's bitten by a dog in Washington State or in Oregon, do we give a rabies vaccine? Anyone? Anyone? Yeah, shrug. I think that's the consensus is sort of a shrug. There's not really very much dog rabies here, as in basically none. And so if it's a known dog, especially if it has known vaccinations, no. And data shows that we really over-vaccinate after most exposures. What about this guy? If this guy bites someone, he looks psychotic. I'm worried. Do we give vaccinations? All right. What about this guy? It's a llama.
Yes.
Also concerning looking. All right. This scenario, we vaccinate?
Wow.
I don't know. So the data for Washington State are pretty good. No recent dog rabies. One dog passed through the state who was thought to have rabies sometime in the last 40 years. But the most recent that I'm aware of was 2015. These are terrestrial mammals, by the way. So 2015, there was a cat in Jefferson County. Before that, a cat in Walla Walla County. Watch out for cats. And in the 90s, there was a llama up there in King County and a horse down in Benton. So I don't know. As far as dogs versus any of these other animals, I'd worry a little more about the other ones. Yeah.
Is the main reservoir we're worried about in Washington the skunk, or?
We'll get into that. Yeah. We'll look at that in a minute. And so who's scarier here? All right, this guy. Yeah. So this is U.S. data for cat versus dog rabies, and cats are much more likely to have rabies. Just the campaign for cats has lagged behind the campaign for dogs to make sure everything is vaccinated against rabies. There are more feral cats, and so you're much more likely to have rabies from a cat bite. And so that's, in my mind, if a dog bursts out of the bush with no collar, frothing at the mouth, and bites somebody, yeah, sure, consider it. I had one case in residency where it was a bite, and they were like, we think the dog was just imported from Belarus or something, and I was like, I don't know, do you have info? And so we wound up giving them shots. You just don't know. But for the most part, probably worry more about cats than dogs. So let's talk a little more about bats, right? So bats are a lot more common as vectors for rabies. And so this is data from a few years ago in Washington. And you'll notice that a lot of counties had positive bats for rabies. Interesting thing here is about 10% of bats that get submitted to counties for testing are positive for rabies. Do you guys think that means that 10% of wild bats are rabid? Probably not, right? These are bats that are like flopping around in this room right now during the day, acting really weird, and somebody's able to catch them and bring them in. And so for bats that are biting people, acting erratically, or able to be captured, those are the ones who are most likely to have rabies, and so it's a higher percentage. But you can see kind of all over, and the map for Oregon looks very similar year to year. Nationwide, these are sort of the more typical terrestrial vectors. So on the East Coast, you got raccoons, and this is a line that is advancing forward. When I did my training in New York, there would be rabid raccoons wandering around Manhattan at like 2 in the afternoon. Just obviously rabid, stumbling in the middle of the day, in the middle of a city. Highly concerning behavior. The kids would go, the families would be like, oh, let's go see the raccoon. Skunks are a really important vector. So up north, that's a big problem. Down south, that's a big problem. And the central states, that's a big problem. Fox are a problem down in Texas. And actually, it's not on here, but there are fox cases in Oregon. So you want to think about that. And then skunks again in California and foxes in Alaska. This is a map globally of where bats exist and number of species. And so bats are pretty much everywhere. If you go to Andy Lux's talk, he's probably not going to talk about bat exposures right there, above 26,000 feet. Otherwise, there's bats everywhere except for the polar extremes. And then this is the overlap of where bats carry rabies, also everywhere. Anyone know who this is? So this was a young woman, it was about 15 years ago, Jana Geis, who was 15 years old, picked up a bat in church that was acting weird. It bit her, didn't think much of it. She went into the hospital about a month later, acting strangely, having difficulty speaking, spiking fevers. And a very astute ICU doctor took over her care who said, I think this is rabies, and managed to make the diagnosis, which alone is kind of amazing because it's a difficult diagnosis to make and not the top of your mind usually for people with encephalitis. And then said, I know this is untreatable, but I'm going to try to treat it. And he came up with the Milwaukee Protocol, different branding, which basically consisted of putting her into an induced coma, giving her antivirals, the idea being, and steroids, and the idea being that rabies doesn't cause a lot of destruction of brain tissue itself. It causes massive inflammation, and it replicates at an accelerated pace above and beyond what the immune system can keep up with. And metabolic demand in the brain just makes that worse. And so he said, you know, I think I can give some antivirals that might help. I'm going to suppress function in her brain so there's less metabolic demand. I'm going to treat other things like SIADH and fevers. And she started waking up on hospital day 30 or so, and they stopped sedating her. She started standing, sitting over the next few days. She learned to speak again. And if you watch videos of her now, you could, you know, knowing her story, you could say, yeah, I think there's probably a mild traumatic brain injury or something there. But she is a fully functional person who went on to finish college and got married and had kids and etc. This is kind of the sentinel case of a person who has been treated and survived rabies. There's a couple others scattered, you know, maybe this happened, but the data's a little less clear. This is the one where it happened. So this sounds great, right? Like maybe there's a treatment, and even if it's not always effective, this is a uniformly fatal disease. And this, just to back up for a second, this is that incubation period we were talking about between when she was bitten and when she became symptomatic. And so a month is sort of a good average, but it can be wildly variable. So then people tried this, and then some papers like this came out. Critical appraisal, this failed approach should be abandoned. Whoa, it's dramatic. And then some other data came out that is hard to track down all of the details of, but is showing survival curves that are better than 0, which sounds also probably like a great idea for a disease that's uniformly fatal. And so there's really some mixed data here. I think in some of this data, there's a lot of confounders, and so it's unclear whether some of these people got one vaccination, like we were talking about before they became symptomatic, so maybe they were really late, but they got one vaccination just in time to give their immune system a little bit of a head start, and they survived more for that reason. It's definitely been tried many times and failed, which is probably to be expected, but under maybe less controlled conditions. There's only a few papers of failures with really great controlled conditions identical to the prior. And so I think this is still a fairly open question in my mind.
Is there a definitive, is it just a clinical diagnosis, or is there a definitive like lab test?
Oh, there's definitive lab tests.
Okay.
It's just very tricky. You're looking at hairs on the back of the neck where it seems to, and salivary samples, and this is samples that need to be sent off to the CDC, and so it's just a challenging diagnosis to make, and you can get a lot of false negatives.
Yeah,
actually.
well, and I was wondering if there are any
Yeah,
maybe false positives mixed in there.
Not so many false positives, but definite false negatives, and even cerebrospinal fluid can be dodgy for making the diagnosis. So we're just going to talk a little bit about how you mitigate this disease, since it's still not very treatable, regardless of what you think of the Milwaukee Protocol. So this is a dog campaign. This is really the biggest thing we're ever going to do globally to reduce rabies risk to humans, is to vaccinate dogs. So this is a campaign in Tanzania. There are campaigns all over the world. They're really effective when they're followed through. And then as far as other terrestrial mammals in the U.S., in Great Britain and other cases, there have been great techniques of putting out bait that's laden with vaccination for animals to find and eat. And this has worked really great and really reduced raccoon rabies in the U.S. It's still a problem on the East Coast, but it used to be a lot more widespread. And so then what do we do about cases like this? How do you vaccinate this bat against rabies? And there's been a lot of techniques used to mitigate bat rabies, and usually it's really ineffective. So one of the things that's done is, this is a bat roost. This is where all the bats live, in a cave or a hollow tree or something like that. They're usually in mixed colonies of different species that live together, which is a really important thing to understand. And so the natural response when this is happening in one of these communities is some of the guys go out, and they're woodsmen. This is what they do. They go out into the woods and make their living. They hunt and they log trees and they do what they do. And so they find these places and they're very capable and they light them on fire. They say we're going to burn out the bat cave and that'll solve it. So in doing that, they'll generally kill off all of the insectivorous bats as well that eat the vectors for other diseases, the fruitivorous bats who pollinate their crops and things like that. It's pretty bad ecologically, it's pretty bad financially for them because these are very important kind of cornerstones of the ecosystem, pretty much anywhere they live. These are also social creatures. Again, cute in the right light, right? They're very social. This is another thing that's been used is this is vamfin, which means end of the vampire, basically. This is rat poison in a gel that's smeared on the bat's back after you catch them in a net. And so they go back, they groom each other, they eat rat poison off of each other, and they die. This also isn't that effective because the bats that are out flying around, really active, are less likely to be rabid. They're more likely to be older bats, and what you leave behind is a bunch of juveniles who are more susceptible to rabies and the ones that already have rabies. And boom, that's like what in forest fire terminology would be called a blow up. It just happens all at once. They all get rabies, and that might be one of the things that's driven some of these outbreaks. Not the greatest technique, but can we take some of this rabies vaccine and include it in some of these kind of gels that are put on the back? And I think this is what we're working towards as far as a vaccination campaign to match what was done in raccoons in this country. You can catch these bats, you can put some sort of vaccine on them that will be groomed by other bats, and that will spread throughout the population wherever they live. There's a lot of barriers to doing this, but I think it's the best idea out there. All right, so we're going to keep moving along and talk about global warming a little bit. Climate change. This is me and my kids doing our part to contribute. And we're going to talk a little bit about birds. So in 2014 and 2015 in the US, there was a bird flu outbreak of H5N2, which infected about 50 million US poultry that died or were culled, meaning killed off to prevent them spreading it any further. It caused about $1 billion in losses to this industry. Just so you know, we have a full picture. This is how some of these cullings happen. They're ready for this, and when the virus starts spreading, they release this foam from some machine in the corner of their giant million chicken warehouse that floods the entire place with foam that hardens, suffocates everything, traps the virus, and then they chop it up into bits and haul it off in a biohazard bag or something. So this is pretty catastrophic for the poultry industry, but didn't really extend into humans this time. Going back a century or so here, the 1918 Spanish flu. This is a pretty early estimate, let's say, where they're saying, I forget how many they said died here, 6 million deaths. It was a lot more than that. It's estimated 20 to 50 million deaths worldwide total during the Spanish flu outbreak. So some of the treatment wards, we'll say, because this is just all the people with flu in one place with a blanket. And so you guys have heard this HN terminology. This is just how we name the influenza viruses, the influenza A viruses that cause these pandemics. And so these are the neuraminidase and hemagglutinin receptors on the surface that really will affect how pathogenic they are and how virulent they are. And one more thing I'll talk about, these, the RNA nucleosome of these viruses is incredible at reassorting. So if you put two viruses in the same cell, they're just going to shuffle like a deck of cards, like immediately, and you get a new virus. And that's one of the tricks with influenza is how, that's why the flu shot works some years and doesn't work other years. We're doing our best guess based on the past 12 months of data of what are going to be the H's and N's that are out there, what are going to be the different reassortments that are most likely. These are some of the big outbreaks that we've had. Interestingly enough, this year, all we've seen is flu B. I have not seen a case of flu A in our emergency department yet. And that probably means that we really hit the nail on the head with our flu vaccine this year overall, as far as the most concerning pandemic-causing strains. And so this was that Spanish flu. There have been various others. This was the H1N1. I'm pretty sure I got this when I was in medical school. These have caused huge pandemics with massive loss of life. And all of these have at least some component of bird flu to them. And so the question is, what are the processes that are driving this reassortment every year? So these are the global migratory pathways of birds in the kind of area in question here, let's say. And so we know that China and Southeast Asia have had massive outbreaks of pretty concerning bird flu viruses that affect humans, among other similar viruses. And we have all these birds that travel down through the continental US and South America, and this is where they all converge, in Alaska in the summer. It's where all these birds come together, and you can literally picture these flocks of millions of birds converging and using the same ponds and the same breeding grounds, and they're hatching their eggs, and then they're all flying back down south for the winter. And so it sets up a process. It's a little bit of a busy slide. We'll kind of walk through it. And so you have in, China is the example here. You have a huge backyard poultry industry where everyone has backyard chickens, and instead of these big factories that we have, they do have those, but there's a large number of kind of free-ranging, smaller scale, rural chicken farms. And then you have wild, mostly waterfowl that are really in direct contact with these groups. And then you have fowl being sold at market, usually alive or recently slaughtered, with potential to infect and go into a human population. Then you have these birds migrating up to Alaska, where they're sharing this virus with migratory birds from North and South America, and then potentially infecting animals and people transcontinentally. Additionally, you have potential exposure for people who are subsistence hunters in Alaska. It's thought to be lower risk, but it's definitely a possibility up there as well. So I want to quickly just show this. I don't think this is going to be too surprising to anyone, but it's good to see. This is global temperatures over the last 50 years or so. And you can imagine that global temperatures have a pretty big impact on bird migration patterns, right? This are a lot of the cues they use are temperature along with the length of day. And so I work with a group that's looking at some of these risk factors and the effect of temperature rise in Alaska on bird interactions and risk for avian influenza. And what you can see here is that these are sightings of the pintail duck, which is just a really common bird out there that's a proxy for birds that migrate to Alaska. And so you can see that as you move further north, the sightings are consolidated within a kind of smaller chunk of time, and meaning that most of the birds that fly there are going to be there for a shorter amount of time interacting. And as you move further south where it's warmer, birds are there for more of the year. And so here you have basically 12 months of potential exposure between potential migratory birds. That exposure basically increases contact time, increases the number of different variants of influenza that are likely to come in contact with each other. And it's just a numbers game of increasing the biodiversity of the influenza viruses of that year, and the probability that one is going to have pandemic potential. And so this situation from the bigger slide has happened multiple times in China, and there was one outbreak that was pretty bad, H7N9 in 2014. 80-something% of these folks had reported a contact with a chicken, usually at the market. 63% of them were hospitalized in the ICU, and 34% died in an urban Chinese ICU. This is not your average flu. This is like hemorrhagic ARDS type picture, just catastrophic pulmonary failure. This scenario that we have over the US right now has not occurred in the US, but did occur in the Netherlands in 2009 with an H7N7 strain, where a farm worker was infected and then passed that infection along to multiple people in the community. Luckily, this was a more kind of typical flu strain. They all got sick, a few of them went to the hospital, nobody died from that. All right. So, I'd like to take another pause for a tangentially related triage. This one's very tangential, and very county hospital. I have internal fleas, and I brought proof. I brought my purse. I'm not high. Do I look high? My skin looks dry, but it's not. I have internal fleas. She didn't have internal fleas, it turns out. Does anyone know where this is? This is Old Lyme, Connecticut. I drove on this road many times going to see my grandparents who live near there. So, Lyme disease originated here. In the 70s, there were these kids getting these weird arthritis-type diseases, and they were diagnosed with rheumatoid arthritis. And somebody said, wait a minute, multiple school-aged children in this small town are getting rheumatoid arthritis? That doesn't make sense. And so I started working on it, and eventually in a lab in Colorado, a few years later, in 1981-82, they were able to identify this culprit. Anyone know the name of this bug here?
Borrelia.
Yeah, Borrelia. So it's a spirochete. It's the causative agent for Lyme disease. And it's carried by this tick, the Ixodes scapularis, black-legged or deer ticks. This is kind of the classic teaching, and we'll go in briefly to how the picture is actually probably a lot more complex than it's in real life. So the general life cycle here is, you know, the tick lays eggs, and the eggs, the larva attached to a mouse because they like smaller prey. Maybe that mouse has been previously infected with Lyme, and then those larvae carry that away, and then they infect other mice, and those mice get bit by the larvae again, and then those attach to deer and humans, and you have adults with Borrelia, and they make people and animals, mostly people, sick. Have you guys ever seen this before? So much more common on the East Coast, and when I was in med school, we'd do a quick skin exam, see this, and treat. There was not a lot of like hullabaloo. It was like obvious what was going on here, but this is the erythema migrans, the target lesion. It's sort of the textbook primary stage of infection with Lyme disease. In reality, it's somewhere around 70 to 80% of people with infections actually get this, and probably only around 70% of people who report having ever been exposed to a tick. So you can't always go off this, and you gotta sort of keep thinking about this. So you can treat this at this stage, and it'll usually go away. If you miss it, or they miss it, or they don't get a rash, and they just feel lousy, and they come in with this. Anyone know what this is showing? I don't know if you guys have studied EKGs much.
Third degree heart block?
Yeah, so this is a third degree heart block. It's a AV node dissociation, and this is this and kind of migrating arthralgias can happen in the secondary stage. The early disseminated stage is known as, and this is a really important one to catch, because if you catch this and you realize it's from Lyme and you treat them, this will probably go away. If you miss it and it persists, they're going to need an implanted pacemaker, which is kind of sad. Somebody's like 25 years old who just tried to go for a hike in the woods. And then third stage, you can cause encephalitis, meningitis, more central nervous system effects. It's a common cause of Bell's palsy, so you want to think about that if you're seeing that. As far as distribution, very classically known to be a disease of the Northeast and the Great Lakes region, but there are cases scattered all over the U.S. And this map fluctuates a little bit year to year, and has changed slightly with a few more cases on the West Coast, though it's not certain if that's just due to increased surveillance and knowledge of the disease or not.
Is Massachusetts just not submitting data there?
Yeah, they're like, screw it, it's everywhere all the time. And so this is a study that looked at antibodies in dogs for exposure as kind of a proxy to how much of it is out there, as opposed to looking how many people get sick. And it's just a countywide distribution of the same map. So it is really scattered through a lot of the U.S. and does involve areas in Washington and Oregon and California and places you would typically not think of Lyme. Looping this back a little bit to the concept of climate change, this is a kind of progressing and changing distribution. And you got to take this data with a little bit of a grain of salt. And to show you why, I'll start with this one. This was a study from 2005 that said that, we think that Lyme disease is going to be extending, and by 2080 is going to reach Canada. It was about 4 years before Lyme disease reached Canada. And this is kind of a newer estimate of where the blue is where we have Lyme disease today, and think we will not in the future. The red is where we will only have Lyme disease in the future, and the beige is kind of both, where it will just persist. So you can see there's some sort of advancement west and a little broadening of the distribution. And this is really the more prevalent areas and not so much these scattered cases. As far as treatment, again, I'll just point out the common thread here: doxycycline, 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 doxycycline. Give them doxycycline, unless they're 8 years old or younger and you don't want their teeth to turn brown, in which case you use amoxicillin. There's other cases where allergies might cause you to use something like azithromycin or something. For CNS Lyme disease, ceftriaxone's usually your first, IV ceftriaxone is going to be your first agent of choice. So, just want to raise concern that as the earth gets warmer, the bat distribution is moving north, the Lyme disease distribution is moving south, the bird flu situation is getting worse. And when these bats start biting these birds, or getting bitten by these ticks, who knows really what's going to happen. It could be a whole new world of pathogens out there. The real point being to vaccinate your pets, ride your bicycle, and I think that's about all we got. This is some of the folks who have helped me with some of these projects, and I'll take any questions. Yes?
I've seen a lot of like recent like mystery diagnosis type of shows where like alternative type practitioners do Lyme like titers.
Yeah.
I'm like curious, like, and they put people on doxy and they say like, oh, you have Lyme and we put you on doxy and it didn't help this like mystery condition. What's your opinion of that?
So it's a huge can of worms is what I'll say.
Okay.
Yes, I'm curious about that also, I'll say. So there are conditions of chronic Lyme. There are treatment failures for Lyme disease.
Yeah.
I think that's a fact. I think there are also probably a majority of these cases of somebody sort of looking for a diagnosis of why I feel like things are not quite right, and a large number of practitioners who are willing to sort of do a diagnosis, you know. The Lyme testing is complicated, and I didn't go into a lot of detail there, but there are a huge number of false positives for having ever been exposed to Lyme before. And maybe those are exposures that were never really clinically significant, but more likely it's just the test is flawed in that way. There are a large number of false positives. And so it's very easy to go out and get, and I've seen this multiple times in the emergency, it's very easy to go out and get tested and say, I tested positive for Lyme, which as a broader, more factual statement is probably false. And I've seen people are coming in getting, IM ceftriaxone twice a week for indefinitely because of this diagnosis, which is a risk of, all kinds of things. That's not very good for you. And so it's tricky. I think it is a diagnosis that some people have and it needs to be figured out. And I think it's also sort of a false diagnosis in a lot of cases. Yeah.
In those studies you mentioned on the Milwaukee Protocol,
Yeah.
did you see or were there any correlations between age and successful treatment?
There are not. There's mostly just data of, I think for the survival curves that I showed, there's kind of a scattering of age ranges and it doesn't seem to make much difference. You would think that a younger person would probably do better, but it's kind of this, it's obviously not an incredibly rare disease, but it's pretty rare that a case is in a place where there's ICU level care to really go through this protocol in a detail-oriented kind of way and really document it. And so I think there's still a dearth of good information out there.
Okay.
Yeah.
Have you seen much antibiotic resistance in the Lyme?
So that's a good question. And yes, there is some, and I think that's something also where the data is muddled by sort of all of these other, who actually has Lyme or who doesn't, who's failed treatment and who hasn't, who ever actually had Lyme to begin with. And so there is some evidence of possible multi-drug resistance, but it's a difficult one. It's one of these spirochetes that's kind of hard to diagnose. You don't just get blood cultures easy to say, aha, Lyme disease, it's growing everywhere. It's kind of insidious and like syphilis or something. It's a little harder to figure out down the line what's actually happening. Yeah.
With the potential severities with rabies, why do we ever, because you were asking us questions as to, who would you give the rabies vaccine to? why would you even? Why not just like err on the side of caution as soon
Yeah.
as you have an inkling about
So
it?
it's I got rabies vaccinated before I went to Peru
Yeah.
for kind of obvious reasons, but I had to fight for it. They said no, the CDC doesn't recommend rabies vaccinations for Peru, and I said I'm going to be going into caves with vampire bats and trying to catch them. And they said, why are you doing that? And that was, and so eventually it took some doing though. And they said, they said over and over, you're going to have to pay for this. And it's, I think it's like $15,000 for the course. And so that's, I can't tell you all the details about why you can get your dog vaccinated for like $20 with one shot and why it's a whole different stories for humans. That's a different talk. So that's one of the major things. It's a major expense. And then there's always, there are risks with, undergoing vaccinations. People can have allergic reactions. And so it's one of these things that you're walking that line of what's the risk, what's the cost, and what's the benefit. And if somebody really does not need it, like if your chance of getting hit by a car or leaving the hospital is a lot higher than your chance of getting rabies, then it's, probably not worth doing in a lot of cases. And this is a funny place to give this talk just because the risk here is so much lower than a lot of other places. But I think if you're in, if you're again in the Northeast even, where there are raccoons everywhere, and you have any kind of exposure there, I think it's a no-brainer. We had a case where someone got attacked by a river otter and got real messy. Like the otter latched onto her face like a cartoon, and it would have been funny except that she required like 3 different surgical specialties to put her back together. And she got rabies vaccinated. We were like, I don't know, that's weird behavior for an otter. I've seen a lot of otters, never seen that. And it's they're a potential vector. They're definitely not common, but they're a vector. Any other questions? Yeah.
Is there any benefit to having a diluted iodine solution for cleaning a rabies bite?
Yeah, that's a good question. So it's not a bad idea, and it definitely is virucidal. Soap and water seems to probably work just as well, but if I saw many bites, then I would do that. I would scrub it with soap and water and put some iodine on there and just kill. One of the interesting things with doing this work in Peru, like the main barrier is actually kind of cultural, kind of belief stuff. And so they kind of had it where what you do for these bites is you put ash on them. And that's what you do. That's what we've always done. That's what you do. That's how you treat these bites. Which maybe for a general wound is not a terrible idea to take a little clean ash from the fire and put it on there. But I think for post-exposure wound care for rabies is probably not ideal. And so trying to kind of change these beliefs was the crux of our time down there, trying to kind of work with people. But that's what we would do, is soap and water and then a little bit of iodine. Yeah?
So it seems like the Milwaukee Protocol, like some people, well, most people maybe not super excited about doing that.
Yeah.
Is there any protocol that you try, or just kind of?
It's, this is the one that's really been described to my knowledge. I think there's been some variations that have been tried. And again, I think the argument against it is cost, is expense and resources. And, if you blew this up to where this is a more and more common problem and the treatment efficacy is 1 in 10,000, are you really going to treat 10,000 people with a month of, $100,000 a day ICU care to save, 1 in 10,000 people? And that's it's a societal question. I think that's the main argument against it. My mind is still that this is a fairly rare process in places where we have ICUs that can do this treatment, and so it's worth continuing to try and or kind of tweak the process and see if we're coming on something that's more predictably curative. Anything else?